This is a short presentation on technology that adds a lot of value to ordinary images, called SmartImages. So this is an image, a great thing, displayable on anything, portable, an essential component of the web, cacheable, understood by browsers and software, standardized in format, and a preferred method of information presentation, a very successful data type. However, it's only a picture of information. It's coloured dots, essentially, and it can't do anything by itself. And because it's only an image, if you want to add context to the image, in other words, to explain what the person is looking at, you need to do quite a bit of work. First of all, you need to support image interactions when a person moves a mouse or touches something or hits a key. You need to be able to formulate queries and send them to databases, to access the results from those databases, format them and return them back to the client side, and all the while being continuously online. And lots of people, including me, have been doing that for years, and it works, but it is not trivial. It requires quite a bit of infrastructure to do. So, what if we could have all the good things about an image, its portability and cacheability, etc., while adding the ability for the image to be context-aware, informative, interactive, updatable, a truly visually indexed information, and deliver this all within the image itself, complete and standalone. And this is what SmartImages can do. So what we're going to do now is cut to a few demonstrations which will actually show different types of SmartImages, and then we'll come back to the presentation. This is a short presentation of SmartImages. We'll start by bringing up a browser. This is a Mozilla browser, and we've created a small add-on which will detect SmartImages. So I'll grab a PNG image and drag that into the browser where it's displayed as a normal image. And when we right-click on this image, we have an option to view it as a smart image. Now, when we do that, the add-on looks inside the image, discovers there's some metadata and actually some other data and indexes, and brings up the title, which is property information, the Sydney CBD, and various properties, property ID, valuation, etc. Now, we have a spatial index so that when we move the mouse around, we're actually identifying the particular property under the cursor and displaying that information. We can also stop that mode, clear the form and the map, and then look for instance, all the properties in George Street, which I know is in the middle of the Sydney CBD. So when we search that there are the George Street properties, we know that there's a York Street on the side there, and in fact a Pitt Street. So we can identify those properties, and of course we could add other variables and search. So what we have here is, inside this image, we've got a full database of the property, plus the methods and techniques we can use to search and display that data, and then we can go back to that normal mode. So that's a very simple version of a smart image. Let's grab this next smart image, and in this case this is the top of the South Island of New Zealand, the northern end, and when we right click and view this one as a smart image, you'll see that there's a title again, but only a single value, a single property. And essentially what we have here is a sort of a raster data set, which is the integer height in meters of any point in the image. So we can see there's 0 at sea level, of course, and various heights. And you can see this is a land use map with the red being the rock, and then there's forest and grassland, etc., and sand, etc. So with this one data set, it's not particularly interesting data, but what we can do is show some of the methods you could use to display this elevation data. So one obvious one is to display it as a range of colors. So we turn on the update, and there is the colors above the image. We can actually change the opacity if we wanted to just see the top, or just a tiny bit of the top. just somewhere in between. Now we can also change the colour range. This represents everything from sea level up to the highest point, that sort of display. We can even change the range so that we're only looking at the various lower layers, say 0 to 55 metres, showing where the areas perhaps prone to flooding are. And we can change things like the number of colours we're using to represent the data. And again, these are normal GIS things that many tools can do. So that's one thing. Another thing that you might want to do is profiling. Here what we're doing is drawing a line across and seeing the height of the data. And as we move the mouse, we can see where it is on the map and also the height displayed there. And we can also hill shade, where we actually take the data and change the intensity of the colour of the pixel based on its angle with the angle of the sun, and we can click and recalculate the hill shade for different sun angles. This is the South Island, so they're mostly going to come from the north, that sort of thing. And then finally, we can also, using WebGL, which is part of HTML5, we can load the data straight into the graphics card, and now we can view the thing in full 3D using basically loading it into the graphics card. We can also do things like change the height of the mountains, make them higher or lower, reinitialize the data, etc. So there's lots of things we can do with this data set. So that's another example of a smart image. Here's a third example. In this case, we have the idea of a smart image as a multimedia container. So I've made it look a bit like a passport, but the idea is that this is a passport for a particular transformer, let's say, in this case, but it could be anything. It could be patient data, it could be any kind of asset, or any kind of area where you want to display different types of information. So in this case, we've got specifications about this particular transformer. We have a calendar view where we can actually look and see what's happened at various dates, and see this is a particular area where a safety test was run, and we have another one there coming up, etc. So we have some activity here, 3-month oil change, etc. So like a schedule for the maintenance of this particular tool. We can have a map view, and of course this could be dynamic, and but it's all self-contained. Occupational health and safety, and then things like audio recordings.
In this circuit, we have 2 independent motor starters
and video
controlled by
Mr. High Voltage is not your friend. So that's the idea. There's various other things you could put into here. This is just an idea of the kind of things that you could put into this image, and when we're finished we close it, and that's effectively a fully self-contained multimedia data set for a particular purpose, particular object. And finally, let's have a look at another product, another smart image here. Let's open it first of all, and you can see there's quite a bit of data in this one. Now, this is actually data from a water utility, and we've got, it's actually for Newcastle, which is north of Sydney, and we've got property ID, pipe size, and other information about properties, etc. So service points, which are these yellow dots, and then we've got sewer lines, which are in red or browny red, and water lines in blue. Now, we can use all the usual zoom capabilities, because this is the real data here, not an image of the data. This is actually the true vector data is here. So we can actually turn on, let's say, let's query the parcels, and we can, as we move around, we can actually view the different parcels. We might also want to query the water lines, so we can actually move along and view the water lines, and as we move around we can see information about the water lines. And the same about the other service points, for example, query the service points and see what they are. So let's look at this another way. Let's just zoom out a bit here. And let's now look, for example, we can turn off the display of everything except the water lines. Zoom out a bit more. And let's query the water lines. Blank the screen and look for all pipes of 150 millimeters. And so search for those, and those are the mains pipes, 6-inch pipes, 150 millimeter pipes. And we can then specify a mode where we go and actually look at each one. There's that particular pipe, and there's information about it, including its unique identifier, etc. So here we have essentially a full GIS capability in an image. And potentially this is updatable, so you could go in and increase the, update the information and then put it all back. And then you've got the data is available to be pulled back out of the image and used to update the central database. So a full GIS in an image. And of course at all times it remains its imageness. So that's it.